Okay, this next video is for experiment 8, which is determining the iron concentration in vitamins. So the first thing that you're going to need to do is you're going to have to use the data to create a standard curve. Once you enter in all the data and create a standard curve, you're going to add the equation to the chart and you'll get the equation. It'll be in a y equals mx plus b format. I made these numbers up. These are not necessarily the numbers for our standard curve that we're using. So if I figure out my standard curve and I'm given an equation, it'll populate on the graph. So let's just say this is my equation, okay? Now, in the experiment, it tells you to take a vitamin and dissolve it in 25 mils of acid, okay? From there, you're going to take that entire thing and put it into a flask and you're going to dilute it up to 100 milliliters. This is going to be considered solution 1. From there, what you would do is you would take 5 milliliters of solution 1, put it into another flask, dilute that to 100 milliliters, and that becomes solution 2. Then you would take another 5 milliliters of solution 2, you would put that into a flask and you would dilute that to 50 milliliters, and that would become solution 3. So what we have here is the serial dilutions. Then what we are going to do, if you were in lab, is you would take solution 3 and you would determine the absorbance of solution 3. Then you would use that to calculate back to get to the original concentration. So let's just say that we take solution 3 and we do the absorbance, and the absorbance comes out to 0.331 grams, okay? You're going to take that absorbance and you're going to put it into your calculation. This is from your standard curve, okay? Where X would be the iron concentration and Y would be the absorbance, okay? M and B obviously are given to you from the standard curve, so we would rearrange this and we would have X equals Y minus B over M. So in this instance, it would be 0.331, which is the absorbance we measured, minus 0.001 over 0.2124. So with this calculation, I come out with my iron concentration being 1.55, okay? Now, that is the concentration of solution 3. Now we have to use that to work our way back to figure out what the concentration was of the tablet that we used. So here you're going to use the C1V1 equals C2V2 calculation. So as you can see, we have our solution 3 concentration, 1.55 milligrams per liter. Okay, we made 50 milliliters of that, so I converted it into liters. We made it from 5 milliliters of solution 2, and the concentration of solution 2 we don't know. Okay, so we go ahead and do that calculation, rearrange for that, we get 15.5 milligrams per liter, and that is our solution 2 concentration. Same thing, we take our concentration of solution 2. As you remember, we made 100 milliliters of that, so this is converted into liters. We used 5 milliliters of solution 1 to make it, and we don't know the concentration. Rearranging for that, we get solution 1 being 310 milligrams per liter, okay? But that is only our solution 1. What they are looking for is the mass of the iron in the tablet. So if you remember, we made 100 milliliters of solution 1. Okay, so we're just going to take that concentration, multiply it by 0.100, and we'll get 31 milligrams. So on your report, you would have your measured absorbance, which in this instance is 0.331. It's asking for solution 3 concentration, which is what you would use the standard curve for. And when we use the standard curve, we came out to 1.55, so that'd be here. Then you're going to do your serial dilutions to figure out your concentration in solution 1, which we did over here. We got 310. And then again, the mass of the iron in the tablet, which we figured out here. You would do this for trial 1 and trial 2 and determine the average. Okay? I hope this helps.